Hello everyone. So today's session is about the oxidation state. So in this session, we will be discussing about the oxidation state definition, and then we will discuss the rules to calculate to determine the oxidation state of an atoms of elements. Okay. So let us discuss the oxidation state first. Now oxidation state is nothing but what? Oxidation state means it is a charge left on atom. Charge left on atom when when all atoms bonded to it all atoms bonded to it are removed are removed. Okay, so oxidation state is nothing but what? It is nothing but a charge left on atom when all atoms attached to it are removed. Okay, so let us apply this definition to to calculate the oxidation state of atom. For example, methane molecule. Okay, methane molecule. So this is the structure of methane molecule. We know that four hydrogen atoms are bonded to carbon in methane molecule. Okay. Now, how to find the oxidation state of each atom? Let us dissociate the bond. So we know that carbon is more electronegative in comparison with hydrogen. Okay, so electronegativity difference is needed to calculate the oxidation state. So we know that carbon is more electronegative in comparison with hydrogen. Okay, so on dissociation of single bond, assign negative charge, -1 charge to the more electronegative atom and +1 charge to the less electronegative atom. Okay. Similarly, on dissociation of second carbon hydrogen bond, -1 charge to the carbon and +1 charge to the less electronegative atom. On dissociation of third carbon hydrogen bond, -1 charge on hydrocarbon and +1 charge on less electronegative hydrogen atom. On dissociation of one more carbon hydrogen bond, -1 charge on carbon and +1 charge on hydrogen atom. Okay. So when we dissociate all bonds, all carbon hydrogen bond, the total charge left on this central carbon atom is equal to sum of the charges -1, -1, -1, -1, which is equal to -4. Okay. So in methane molecule, what is the oxidation state of carbon? In methane molecule, oxidation state of carbon is -4. While oxidation state of hydrogen, so on each hydrogen, what is the charge? +1, here also +1, +1, and +1. So on each hydrogen, oxidation state of hydrogen is +1. So in methane molecule, what is the oxidation state of carbon? It is +4, while oxidation state of each hydrogen atom is +1. Okay. Now second example, ammonia molecule. Ammonia molecule. In ammonia molecule, the structure of ammonia is nitrogen is bonded to three hydrogen atom. Okay. Now, when we dissociate a bond between nitrogen and hydrogen, we know that nitrogen electronegativity is more in comparison with hydrogen. That is, nitrogen is more electronegative in comparison with hydrogen atom. Okay. Now, dissociate a nitrogen hydrogen bond. On nitrogen hydrogen bond dissociation, assign negative charge to more electronegative atoms. Okay, so nitrogen is more electronegative, so assign -1 charge to nitrogen and +1 charge to hydrogen atom. On dissociation of second nitrogen hydrogen bond, assign -1 charge to nitrogen and +1 charge to hydrogen atom. On dissociation of third bond, -1 charge on nitrogen, +1 charge on hydrogen atom. So on dissociation of all these three bonds, so total charge left on nitrogen is -3. The sum of charges is -1, -1, -1, which is equal to -3. So -3, this is the oxidation state of central nitrogen atom. What is the oxidation state of hydrogen then? On each hydrogen, what is the oxidation state here? On each hydrogen, charge is +1. So each hydrogen oxidation state is +1. Okay. Now let us take another example. Next example is H2SO4. H2SO4. This is a structure of sulfuric acid, H2SO4. sulfuric acid. Let us find the oxidation state of central sulfur atom. We know that oxygen is more electronegative in comparison with sulfur. Okay, so oxygen and sulfur belongs to the same group of the modern periodic table. We know that on moving down the group of electronegativity decreases. So oxygen is more electronegative in comparison with sulfur atom. Now, dissociation of this oxygen sulfur single bond. Since oxygen is more electronegative, so assign -1 charge to oxygen and +1 charge to the less electronegative atom. Sulfur less electronegative, so assign +1 charge to sulfur atom. Similarly, on dissociation of these two bonds, when we dissociate two bonds, assign +2 charge and -2 charge. -2 charge to the more electronegative atom, -2 charge to more electronegative, and +2 charge to the less electronegative atom. Similarly, on dissociation of this single sulfur oxygen bond, assign +1 charge to sulfur, -1 charge to oxygen atom. On dissociation of this sulfur oxygen bond, sulfur +2 charge, oxygen -2 charge. Now calculate total charge. Total charge +2, +1, +2, and +1. So what is the total charge on complete dissociation? On complete dissociation, what is the total charge on central sulfur atom? So total charge left on central sulfur atom is +2, +2, +1, +1, which is equal to +6. So +6 is the oxidation state of central sulfur atom. Okay. So by using the definition, if we dissociate the all bonds attached to the central atom, then it is possible to calculate the oxidation state of that central atom or any atom. Next example is chromium oxygen 5. So structure of this compound is chromium. It has butterfly-like structure. Now we know that oxygen is more electronegative in comparison with the chromium metal. Oxygen electronegativity is more in comparison with the chromium metal. Now dissociate the bond between the chromium and oxygen. We know that oxygen is more electronegative than chromium atom, right? So on dissociation of this single bond, the chromium assign +1 charge to more more electropositive element. Okay, so chromium is more electropositive element, +1 charge, and oxygen it is more electronegative with respect to chromium, so assign -1 charge to oxygen. Similarly, on dissociation of the second chromium oxygen bond, assign +1 charge to chromium and -1 charge on oxygen. On dissociation of third chromium oxygen, +1 charge to oxygen, -1 charge to oxygen atom, and +1 charge to chromium. On dissociation of fourth bond, of chromium +1 charge, oxygen -1 charge. Okay, now one oxygen is bonded via double bond to the chromium atom. So on dissociation of this double bond, assign -2 charge to oxygen and +2 charge to the more electropositive chromium atom. Now what is the total charge? +2, +1, +1, +1, +1. So total charge on central chromium atom is, so addition of the charges, +1, +1, +1, +1, +2. Total charge is +6. So +6 is the oxidation state of central chromium atom. Okay. Now we'll discuss how to calculate the oxidation state by using rules. Okay. So first we'll discuss the rules to calculate the oxidation states. Rules to determine oxidation state of oxidation state of an atom. Rules to determine oxidation state of an atom. So rule number one is oxidation state of an atom in free state, that is elementary state is equal to 0. Oxidation state of element or atom in elementary state, that is in free state. Free state means what? Uncombined state. Free state is nothing but what? Uncombined state. Uncombined state is taken as zero. For example, we know that metals exist in atomic form of metal, for example, copper, gold, silver, or for example, sodium, magnesium, calcium. So here, in this atomic form, in the free state, the oxidation state is taken as zero. Similarly, the non-metals such as nitrogen, oxygen, ozone, then molecule chlorine, fluorine, bromine, sulfur, phosphorus. So for these elements, oxidation state is equal to zero. So in elementary state, oxidation state of element is taken as zero. Okay. Now rule number two. Rule number two is rule number two. Oxidation state of alkali metals in their compounds, in their compounds is equal to plus 1. So oxidation state of alkali metals in their compound is always equal to plus 1. For example, sodium hydroxide, potassium oxalate, potassium sulfate. Okay, then potassium sulfate, cesium hydroxide. So in all these compounds, so all the compounds of alkali metals, in all compound of alkali metals, oxidation state of alkali metal is always equal to plus 1. Here, oxidation state of this sodium is plus 1, potassium is present in plus 1 oxidation state, this potassium and potassium sulfate also present in plus 1 oxidation state, cesium oxidation state is also equal to plus 1. So oxidation state of alkali metal is always equal to plus 1. Now next rule is rule number 3. Oxidation state of alkaline earth metals. Alkaline earth metals. Oxidation state of alkaline earth metals in their compounds is equal to plus 2. Okay, so oxidation state of alkaline earth metals. For example, alkaline earth metal, for example, magnesium hydroxide. Magnesium hydroxide. Okay, so magnesium is alkaline earth metal and its hydroxide, magnesium hydroxide here, oxidation state of magnesium is plus 2. Oxidation state of magnesium is plus 2. Then sulfate, calcium sulfate. Next example is calcium sulfate. Here also oxidation state of calcium is plus 2. Then calcium nitrate. Calcium nitrate. Here also oxidation state of calcium is plus 2. Okay. So alkaline earth metal, why they show plus 2 oxidation state in their compound? Because due to the availability 2 electrons in their valence shell, they easily lose 2 electrons and shows plus 2 oxidation state in their compounds. Now, next rule is rule number 4. Rule number 4 is about oxidation state of fluorine. Oxidation state of fluorine in its compound is always equal to minus 1. So we know that fluorine is most electronegative element in periodic table. Because of most electronegativity of the fluorine in periodic table, its oxidation state in compound is always equal to minus 1. For example, hydrogen fluoride. Hydrogen fluoride oxidation state of fluorine is minus 1. Next example is any type of compound of fluoride, oxidation state of fluorine is always equal to -1. Next example is oxygen difluoride, dioxygen difluoride. In these compounds, oxidation state of fluorine is always -1. Always minus. So all type of fluorine compounds, oxidation state of fluorine is always equal to minus. Next rule is about oxidation state of hydrogen. Oxidation state of hydrogen in its compound is +1. Oxidation state of hydrogen in its compound is +1 except except metallic hydrides. Except metallic hydrides. In all type of compounds, hydrogen oxidation state is generally +1 oxidation state. Hydrogen shows +1 oxidation state in most of its compound except metallic hydride. In metallic hydride oxidation state, here in metallic hydride oxidation state of hydrogen is -1. Of hydrogen is -1 in metallic hydride only, but remaining all type of compounds, oxidation state of hydrogen is +1. For example, if you take compound HCl, halide, in HCl, oxidation state of hydrogen is +1. In water, oxidation state of hydrogen is +1, except in case of metallic hydrides. So metallic hydrides, for example, metallic hydride, sodium hydride, calcium hydride, magnesium hydride, barium hydride, or potassium hydride, barium hydride. So here in metallic type of hydrides, oxidation state of hydrogen is equal to -1. -1. In metallic type, all these hydrides, oxidation state of these hydrogen atoms specifically is -1. But remaining all type of compounds, oxidation state of hydrogen is +1. Next rule is rule number 6, related to the oxidation state of oxygen. Oxidation state of oxygen in its compound is -2, except in peroxide, superoxide, peroxide, superoxide, and fluorides and fluorides. So there are total 3 exception cases to the oxidation state of oxygen. Generally, in general, in most of the compound, oxidation state of oxygen is -2. For example, water molecule. For example, water oxidation state of oxygen is -2. For example, potassium hydroxide oxidation state of oxygen is -2. Sodium sulfate oxidation state of oxygen is -2. Potassium carbonate oxidation state of oxygen is -2. So in all type of compounds, carbonates, sulfates, nitrates, oxalate, hydroxide, oxide, oxidation state of oxygen is -2. So some few exception cases such as the peroxide, superoxide, and fluorides. In peroxide, oxidation state of oxygen is -1. In superoxide, oxidation state of oxygen is -1/2. While in if we take example of oxygen difluoride, if we take example of oxygen difluoride, then oxygen oxidation state is +2. While in dioxygen difluoride, oxidation state of oxygen is +1. +1. Okay, so in fluoride, oxygen difluoride, oxidation state of oxygen is +2, while in dioxygen difluoride, oxidation state of oxygen is +1. Now let us draw the structure to find this +2 oxidation state in case of oxygen difluoride. In oxygen difluoride, this is the structure. Oxygen difluoride, oxygen is bonded to chlorine like a water molecule. Now we know that fluorine is more electronegative. Fluorine is more electronegative. So when we dissociate the bond, assign negative charge, -1 charge to the more electronegative atom, that is fluorine, and +1 charge to the less electronegative atom. Similarly, on dissociation of second bond, assign -1 charge to more electronegative atom and +1 charge to the more electropositive atom. Comparative to the fluorine, oxygen is more electropositive. Okay, or we can say that oxygen is less electronegative in comparison with fluorine. Now, what is the total charge? So, total charge on this oxygen is equal to plus 2. Total charge on oxygen is equal to plus 2. So, plus 2 is the oxidation state of oxygen atom in oxygen dichloride. And in dioxygen dichloride, what is the oxidation state? This is the structure of dioxygen dichloride. Now, when we dissociate the bond, so on dissociation, what will happen on dissociation of oxygen fluorine bond? Fluorine was electronegative, assign -1 charge to the fluorine and +1 charge to the oxygen atom, because oxygen is less electronegative in comparison with the fluorine atom. Now, between oxygen oxygen, there is no electronegativity difference. So, charge on oxygen 0, 0. Now, what is the charge on this oxygen atom? Charge is total charge is equal to +1. So, +1 is oxidation state of oxygen in dioxygen difluoride, right? Okay. Now, rule number 6. Next rule is rule number 7. Rule number 7 is, in rule number 7, in complex ion, sum of oxidation state of atoms is equal to charge on charge on ion. In complex ion, sum of oxidation state of atoms is equal to charge on that ion. For example, sulfate ion. What is the oxidation state of oxygen? Oxidation state of oxygen in sulfate, oxide, hydroxide, carbonate, nitrate is equal to -2. We don't know oxidation state of sulfur atom, so let us consider oxidation state of sulfur atom is equal to X. Now, rule number 7 states that the sum of oxidation state of atoms, constituent atoms in complex ion, is equal to total charge on ion. So, how many sulfur atoms are there? Only one sulfur atom. So, 1 into oxidation state of sulfur, 1 represent what? Number of atoms of sulfur, plus 4 into oxidation state of oxygen is -2, and total charge. What is the total charge on ion? This total charge on ion is -2. So sum is equal to total charge on the ion -2. So what is the value of x? X is equal to -2 plus 8, which is equal to +6. So in sulfate ion, oxidation state of sulfur is equal to +6. Okay. Next example is oxalate ion. Second example, oxalate ion C2O4 -2. Oxalate ion. Now in oxalate ion, oxygen oxidation state is equal to, we know that oxidation state of oxygen is -2. Let us consider carbon oxidation state is equal to Y. Okay, how many carbon atoms are there? 2. So take a sum of the oxidation state of constituent particles of this oxalate ion. So there are 2 carbon atoms, 2 into what is the oxidation state of carbon? Y, plus 4 into what is the oxidation state of oxygen? -2. Total charge is equal to -2. Total charge on this ion is -2. Total charge is equal to -2. Let us calculate the oxidation state. 2y -8 is equal to -2. What is the value of y? Y is equal to +3. Y is equal to +3. So oxidation state of carbon in oxalate ion is +3. Next example Cr2O7 -2 ion, dichromate ion. In dichromate, find oxidation state of chromium. We know that oxidation state of oxygen is -2. Chromium, let us consider oxidation state of chromium is X. How many chromium atoms are there? Two chromium atoms. So 2 into oxidation state of chromium is X plus 7 oxygen atom. And what is oxidation state of oxygen? We know that oxidation state of oxygen is -2. Total charge is equal to 0. So 2x plus minus 14 is equal to 0. X is equal to total charge in this complex line is not 0. Total charge is equal to what? Total charge is equal to this -2, right? So total charge is -2. So 2x is equal to -2 plus 14, which is equal to 12. So what is the value of x? X is equal to 6, right? So oxidation state of chromium is equal to +6 in dichromate ion. +6 in dichromate. Next rule is rule number 8. In neutral compound, sum of sum of oxidation state of atoms, that is constituent particles, is equal to 0. Okay, if the species is neutral, in neutral compound, the sum of oxidation state of constituent particles is always equal to 0. For example, nitric acid, HNO3. Nitric acid, HNO3. There is no charge on nitric acid, okay? We know that oxidation state of hydrogen is +1. Oxidation state of hydrogen is +1. Oxygen oxidation state is -2. Nitrogen oxidation state we don't know. Let us consider it is X. How many hydrogen atoms are there in nitric acid? Only one hydrogen. So 1 into what is the oxidation state of hydrogen? +1. Plus, how many nitrogen atoms are there? Only single nitrogen atom. So 1 and oxidation state of nitrogen is X. Okay, so this +1 is oxidation state of hydrogen. X is oxidation state of nitrogen. Plus 3 into oxidation state of oxygen is -2. -2 is oxidation state of oxygen. So the total charge is equal to 0. Okay, there is no charge on nitric acid. Total charge is equal to 0. So if we substitute all these values, okay, let us calculate now. So what is the value? 1 plus x minus 6 is equal to 0. So x is equal to +5. Oxidation state of nitrogen in nitric acid is equal to +5. Next example, sulfur trioxide. In sulfur trioxide, oxidation state of oxygen is -2, and sulfur oxidation state, let us consider it is equal to 1. Now, so how many sulfur atoms? Only one sulfur atom is there. So only one sulfur atom. 1 into oxidation state of sulfur is Y. How many oxygen atoms are there? 3 oxygen atoms. So 3 into -2. 3 into -2. Total charge on molecule is equal to 0. Total charge is equal to 0, right? So Y equal to +6. Y is equal to +6. The charge on the central sulfur atom is equal to +6. Next example, H2C2O4, oxalic acid. H2C2O4. Oxidation state of oxygen in oxalic acid, in oxalate ion or oxalic ion is equal to -2. Oxidation state of hydrogen is +1. We don't know oxidation state of carbon. So let us consider oxidation state of carbon is equal to X. How many hydrogen atoms are there? 2. 2 into +1. +1 is the oxidation state of what? +1 is the oxidation state of hydrogen atom, right? +1 is the oxidation state of hydrogen atom. Then how many carbon atoms are there? Total 2 carbon atoms. So 2 into oxidation state of carbon. X is the oxidation state of what? Carbon. Plus 4 into oxidation state of oxygen. 4 into what is the oxidation state of oxygen? -2. Total charge is equal to 0. Right? So 2 plus 2x. 2 plus 2x. 4 into minus 2 is equal to minus 8 is equal to 0. So x is equal to plus 3. X is equal to plus 3, right? So by applying all these rules, we can easily calculate oxidation states of all elements, all constituent particles of a given compound. Okay, let us discuss few more examples. Next question is, next example, carbon suboxide, carbon suboxide. Formula of carbon suboxide is C3O2. C3O2, an actual structure of this molecule. First, calculate oxidation state of carbon. Then, after that, we can calculate oxidation state of carbon by using structure also. So let us calculate first oxidation state of carbon from given molecular formula. We know that oxidation state of oxygen is -2, right? So substitute value of oxidation state of oxygen is -2, and carbon oxidation state is equal to carbon oxidation state is equal to X. Carbon oxidation state is equal to X. Now, so here three carbon atoms are there, right? Three carbon atoms, so 3 into X plus two oxygen atoms, 2 into -2. Total charge, okay, it is neutral molecule, there is no charge, total charge is 0, right? So total sum of oxidation state of constituent particle is equal to is equal to 0, right? So by substituting the value, 3x minus 4 is equal to 0, x is equal to plus 4 by 3. So what is the oxidation state of carbon here? Plus 4 by 3. Now let us solve the oxidation state. Let us calculate oxidation state from its structure by using structure. Actual structure of carbon suboxide is, this is the structure of carbon suboxide. Now here on dissociation, we know that oxygen is more electronegative in comparison with carbon. So because of more electronegativity of oxygen, when we dissociate the bond, assign negative charge to the oxygen atom, right? So here we are dissociating the two bonds. So when we dissociate two bonds, assign -2 charge to the more electronegative, that is oxygen atom. So here assign -2 charge to oxygen and +2 charge to the less electronegative atom. Carbon is less electronegative in comparison with oxygen. Similarly, here also -2 +2. Now, on dissociation of carbon-carbon bond, carbon-carbon, there is no electronegativity difference, so assign 0 charge, 0. Similarly, on dissociation of carbon atom, carbon 0, 0. So, what is the total charge? Let us find total charge on each carbon. First, calculate total charge on this carbon. So, what is the total charge on this carbon atom? +2 plus 0 is equal to +2. Total charge on central carbon is total charge 0 plus 0 is equal to 0. Then total charge on this carbon atom is equal to +2 plus 0 is equal to +2. Okay, so now here on central carbon atom, what is the total charge? Central carbon atom total charge is equal to, on central carbon atom, what is the charge? 0. Now let us take an average charge. Let us find the average oxidation state of carbon. So average oxidation state of carbon in carbon suboxide, C3 oxygen 2. In carbon suboxide, average oxidation state is sum of oxidation state of carbon +2 plus 0 plus 2 divided by total number of carbon atoms. How many carbon atoms are there total? 3 carbon atoms divided by total 3. So plus 4 by 3. Plus 4 by 3. So 4 by 3 is nothing but what? It is nothing but average oxidation state. So when we apply the formula, by applying the formula, we get the average oxidation state of atoms, because in some compounds the atoms exist in different oxidation state. In carbon suboxide, carbon exists in two different oxidation state. In such a cases, when we apply formula, we get average oxidation state. Next example is next example. Tetrathionate. Okay, so this is an example of a tetrathionate. So in tetrathionate, uh, dissociate the bond. Let us find the oxidation state here in tetrathionate for sulfur atom. Dissociate the bonds. On dissociation of these bonds, on dissociation of these two bonds, oxygen is more electronegative, assign -2 charge to oxygen and +2 charge to the sulfur. On dissociation of second oxygen sulfur double bond, assign -2 charge to oxygen and +2 charge to the central sulfur atom. Then on dissociation of sulfur oxygen single bond, assign +2 charge +1 charge to the sulfur and -1 charge to the oxygen atom. So on dissociation of single sulfur oxygen bond, assign +1 and -1, while on dissociation of two sulfur oxygen bond, assign +2 and -2 charge. On dissociation of sulfur-sulfur bond, on dissociation of this sulfur-sulfur, there is no difference in electronegativity. In such a cases, assign zero charge. Now find what is the oxidation state of sulfur. So let us calculate. Let us take a sulfur sum of oxidation state on this sulfur atom is +1 +2 +2 +0 is equal to +5. Similarly, on this sulfur atom also will get +5 oxidation state. Now let us calculate the oxidation state on the breached sulfur atoms. So when we dissociate this bond, 0, 0, because there is no difference in electronegativity. Similarly, on dissociation of this bond, 0, 0. So what is the total charge on this sulfur atom? 0. Total charge on this sulfur atom is also equal to 0. So total charge on this sulfur, 0 plus 0 is equal to 0. Similarly, on this sulfur atom also, 0 plus 0 is equal to 0. So here also, let us take a average oxidation state for sulfur atom. So average oxidation state of sulfur in S4 oxygen 6 minus 2, that is tetrathionate is equal to, take a average, plus 5 plus 0 plus 0 plus 5 divided by how many sulfur atoms total? 4, which is equal to 10 divided by 4. 10 divided by 4, which is equal to 2.5. So average oxidation state of each sulfur atom in tetrathionate ion is equal to 2.5. Next example case. Next example. Br3 oxygen 8. Br3 oxygen 8. Next example is Br3 oxygen 8 tribromo octa oxide. In Br3 oxygen 8, we know that oxidation state of oxygen is -2. Oxidation state of bromine, let us consider it is equal to X. So how many bromine atoms are there? 3 bromine atoms. 3 into oxidation state of bromine X plus. How many oxygen atoms? 8. 8 into oxidation state of oxygen -2. Total charge on Br3 oxygenate is equal to 0. Okay, so 3x equal to 16, x is equal to 16 by 3. 16 by 3 is the oxidation state of each bromine atom in Br3 oxygen 8. Now let us draw the structure. From structure also calculate oxidation state of Br3 oxygen 8. This is the structure of Br3 oxygen 8. Now dissociate the bond between oxygen and bromine and find the oxidation state of each bromine atom. Now when we dissociate these bonds, here oxygen is more electronegative, assign -2 charge to oxygen, +2 charge to bromine. On dissociation of second is bromine oxygen bond, plus 2 charge to bromine, minus 2 charge to oxygen. On dissociation of third bromine oxygen bond, double bond, minus 2 charge to oxygen, plus 2 charge to bromine. So and on dissociation of bromine bromine, there is no difference in electronegativity, right? So assign plus 2 charge, 0 charge, 0 0. So what is the total charge? Total charge on terminal bromine atom is equal to plus 2 plus 2 plus 2 plus 0 is equal to plus 6. And similarly on this terminal atom also, total charge is plus 6, plus 6 oxidation state. Now find oxidation state of central bromine. Now for central bromine, dissociation of this bond, plus 2 charge, minus 2 charge on oxygen. Similarly on dissociation of this bond, plus 2 charge, minus 2 charge on oxygen atom. And bromine bromine dissociation 0 0. So what is the total charge? Total charge on central bromine is plus 4, plus 4 total charge. So take an average now. So what is the oxidation state? Average oxidation state of bromine. Average oxidation state of bromine in Br3 oxygen 8. Br3 oxygen is equal to plus 6 plus 4 plus 6 divided by how many bromine atoms? Total 3 bromine atoms are there. So this is equal to 16 by 3. So 16 by 3 is the average oxidation state of bromine atom, but the individual oxidation state of bromine is different. Okay, so in some compound, the individual oxidation state is different, may or may not be different, may or may not be same as that of the average oxidation state. So in some compound it is different because in compound the atoms exist in different oxidation state. Next example is next example H2S2O3. This is a structure of H2S2O3. H2S2O3. Here find the oxidation state of sulfur atom. So first let us apply, let us dissociate the bond and find the oxidation state for sulfur atom. Now what is the oxidation state here of this terminal sulfur? देखो here sulfur sulfur double bond is there. This terminal sulfur is present in sp2 hybridized form, while the central sulfur atom is present in sp3 hybridized form. sp3 hybridized form. Okay, we know that sulfur in sp2 hybridized form is more electronegative than sulfur in sp3 hybridized form. So because of this more electronegativity of the sulfur in sp2 hybridized form, when we dissociate this bond, assign minus 2 charge to the terminal sulfur while plus 2 charge to the central sulfur atom, because sp2 hybridized sulfur is more electronegative due to more percentage of s character. Due to the more percentage of s character, here percentage of s character is more in terminal sulfur in comparison with that of the central sulfur atom. So terminal sulfur assign negative charge, minus 2 charge to the terminal sulfur atom. Okay, and the remaining cases we know that oxygen is more electronegative. So on dissociation here, oxygen minus 1, sulfur plus 1. On dissociation of sulfur oxygen double bond, oxygen minus 2, sulfur plus 2. And on dissociation of remaining sulfur oxygen bond, oxygen minus 1, sulfur plus 1. So find the oxidation state of central sulfur, plus 2, plus 1, plus 1, plus 3. So what is the total charge? Total charge on the central sulfur atom. What is the total charge? Plus 2, plus 2, plus 1, plus 1 is equal to plus 6. Oxidation state of central sulfur atom is plus 6, while terminal sulfur atom, this terminal sulfur atom oxidation state is minus 2. When we calculate, let us calculate now by using by using the rules of oxidation state calculation. We know that oxidation state of this oxygen atom is equal to minus 2. Minus 2. Oxidation state of sulfur, let us consider it is Y. In oxidation state of hydrogen, let us consider it is equal to plus 1. Okay. So 2 hydrogen atom, 2 into plus 1, plus 2 sulfur atom, 2 into Y, plus 3 oxygen atom, so 3 into minus 2. Total charge is equal to 0. There is no charge is given, so total charge is 0. Now let us calculate its value. 2 plus 2y minus 6 is equal to 0. So 2y is equal to 2y is equal to 4, y is equal to 2. So 2 is a average oxidation state of sulfur atom. Average oxidation state of sulfur. Here also we can take from structure. Let us find average oxidation state also, because the individual oxidation state of sulfur atoms is different. In structure, individual oxidation state of sulfur is, so first now calculate average oxidation state here. So average oxidation state of sulfur in H2S2O3 is equal to two sulfur atoms are there. One sulfur atom is present in -2, while second sulfur atom is present in +6 oxidation state. Take a average. Average is equal to +2. Average is equal to +2, right? So here in H2S2O3, oxidation state of sulfur, average oxidation state is +2. While individual oxidation state of sulfurs are different, that is -10 plus 6 in H2S2O3. Okay, so by using these rules, we can easily calculate oxidation state of atoms present in a molecule in combined form or uncombined state. Thank you everyone guys. Thank you.